I'll get out 4-7.
I will. Negative pi over 2. I called you mom.
It's not the first time.
I feel like that happens all the time.
It happens all the time.
Call Earthling too. You have problems.
Paul, are you done with screen?
Yes, he is.
When in doubt, pinky out.
I did not fit. Okay, we ended here, I believe, with the little happy calculator.
Oh, right here.
Okay, this next two are just to show you where the buttons are. I think you know it, but so cosine inverse. Do you see it?
Is it possible to divide 0 by itself?
No.
Because I wonder if there's an exception for one. Like, what would be more confusing, dividing a whole number by 0 or dividing 0 by 0? What would make less sense?
Both are bad. Okay. So let's all start on radian mode just for consistency, because that's what I'm on right now. Radian mode. And cosine inverse of negative 0.853. So second cosine negative 0.853. So this is going to spit out to you in radians. So you get 2.593 radians.
Graph it. That's easy.
And then if you want it in degrees, you just can simply switch modes. Technically, you could convert it if you wanted to, but no need. Just do the same thing. If you change it to degree mode, you'll now be in degrees, 148.539. Degrees. Okay. So practice one on your own. Do you remember arc sine is equivalent to? Yeah, all right, so try this one. Both modes. Pete, what did you get for one of them?
For radians, right at 0.734.
All right, and the other one?
For degrees, I got 42.07.
For degree? All right, cool. All right. Next. I love these ones. These are so nice. Okay. Do you remember yesterday when we were doing these problems? This represented a ratio, right? And then the angle we got out of it, or sorry, we got an angle out of it, right? This represents what angle has a tangent of rad 3, and you got like 5/3. Yes? Okay. So would you agree then that the inverse of anything represents some angle? We could call it theta, because we did use theta for an angle, right?
Yep.
Okay, so call that theta with your best squiggly bracket you can make. Right? It's okay, whatever it looks like. Now, x is a ratio. Technically, x is over what number? 1. Okay. So what I'm going to do is I'm going to draw a right triangle. I'm going to put theta in there. And doesn't the inside in there in parentheses say that theta has a cosine of x over 1? Meaning the adjacent leg is x and the hypotenuse is 1. Good me so far?
Yeah.
And then you now have to apply the cotangent. I need to take cotangent of theta. Well, cotangent is the adjacent leg over the opposite leg, right?
Yeah.
But we need the opposite leg. How do we get it? Some p bag, right? So let's call it b.
Did you say P bag?
P bag. That's what all the cool kids call it.
P fag.
Okay, so x squared plus b squared equals 1 squared.
I'm sorry, Ryan. I just want to be friends with you.
Okay, subtract x squared over, so b squared equals 1 minus x squared. Square root. Don't do anything illegal right here, please. Technically, you'd have a plus or minus, but that doesn't make sense because of side length can't be negative, right?
Yeah.
So we're just going to take the positive 1 minus x squared. So I'm going to go ahead and put that up here. So therefore, the answer is the cotangent of our picture here. So that would be the adjacent leg x over square root of 1 minus x squared. Isn't that cool? Find those in your branch. You do not have to rationalize. Okay?
Cotangent adjacent over opposite is opposite over adjacent.
Adjacent over opposite. Because remember in SOHCAHTOA, the TOA part? You remember this?
Yeah.
Tangent is opposite over adjacent, so cotangent is the other way. All right, let's try one more of those. Same idea. This is over 1. This represents an angle. Should have given you something other than cosine, oh well. Okay, so adjacent, hypotenuse. Sine, we're gonna need the opposite leg, right? So go ahead and solve for that opposite leg. Hey, when you square 3x, do you only square the x? Okay. Just making sure. Let's do this.
What's
Got him.
What's the difference between arcos and secant? I mean, what's the difference between bit, arcos, and secant?
Secant is 1 over.
Oh,
Our
whereas,
cosine is the inverse. As in switching the x. I need you to solve this.
but doesn't the math come out? You know what?
No, it doesn't. All right, guys, look up here. So a few of you, as I looked around, forgot. What's really important would be those parentheses around the 3x, so you're gonna forget to make that 9. So 9x squared plus b squared is 1. So b is squared is 1 minus 9x squared. So b is the square root of 1 minus 9x squared.
Isn't that just 1 minus 3x or no?
Nope, it's not.
No,
And I was
no.
waiting for somebody to say it, and I don't want to go off on a tangent, but no.
Because that's all one number.
I always give this example real quick. Is this 2 plus 3?
No.
Never.
Is the radical of 13 5?
No.
That's what you're saying. No. When they are
That's what I
separated
thought.
by plus and minus, you cannot separate it like that. However, is this true?
Yes.
Yeah.
Yes.
Is the square root of 36 equal to 6?
Yeah.
That's legal. Division is acceptable. Okay. So answer would be opposite over hypotenuse. So just 1 minus 9 x squared under the rad.
So your final answer should be basically what is outside of the grids, like that is what you're going based off, right?
Yeah, you're doing sine of theta.
That.
Remember we call this whole thing theta?
Yes.
There we go. Okay, one more slide,
Why did you make the data into a guy?
because he looks like he got a spooky hat on,
Yeah.
and because I wanted to. All right, to recap from yesterday, and you may want to draw this again. I'm not actually going to put ASTC on there, because I feel like that sometimes misleads you. Okay, yesterday we talked about where the inverses give us answers. This is 0, right? This is pi. That's where cosine inverse lives. Cosine inverse. Your answer will either be in quadrant 1 or quadrant 2. If it's positive ratio, it's in quadrant 1, yes? Negative ratio, quadrant 2. The other two are measured this way, from negative pi halves to pi halves. And those are going to be either in quadrant 1 or 4. Sine inverse and tan inverse. So what I've added is that idea of the composition like we just did. You know how there was an inside and an outside? So we're doing that now. So we start just like we would, remember a long time ago when I would give you something like that? Right? You start on the inside, then you apply the outside. That's what we're doing here. Okay. So if my ratio is positive 1 for tangent, am I on 1 or 4? Okay. And I have a 1 ratio, so 1, 1, which makes the reference angle 45.
45 degrees.
And I'm not going to worry about radians right now. This whole thing, so the inside represents 45 degrees. Which is along the same lines. Remember back here I said, oh, this represents an angle. This time we actually just have the number for it.
I have a question. What is the -1 exponent? Does that mean inverse? Or-
Yeah.
Yeah. So there are two ways of writing it.
Arc, yes, arc or
-1.
Now you just take, this is back, we're back to old problem now. Sine of 45. We just use this picture, right? So sine of 45 is 1 over rad 2, which is rad 2 over. See how we kind of like went backwards and then forwards? Okay. Let's try another one. Now we're going to go forwards and backwards. Check this out. That's just a regular problem, right? Tan of pi fourths. And guess what? We already drew the picture up there. So what's the tangent of pi fourths? 1. So all of the inside is just 1. Now I need to do arc cosine or cosine inverse of 1. Thoughts?
Since cosine is the x value, wouldn't that be either 0 or 360?
I like his thinking. Now, only one of those answers is right. Is it 0 or 360?
0.
It's 0 because look, your answer has to be between negative pi halves and pi halves. So 0, right? And this was a special case because, and Nick said it nicely, cosine is the x-coordinate, and the x-coordinate is 1 when the angle is 0 degrees or 0 radians. Okay? I always do a square around the circle instead of circle, because then it's a donut. All right, forwards. What's cosine of pi? Yeah, -1. All right, now we're going backwards. Tan inverse of -1. So where's tan negative? 1 or 4?
4.
And reference angle?
45.
And you gotta be a little careful here because you're gonna be tempted to measure it like that.
Oh, but no.
What's it gonna be? Who said it? I knew it was you.
Who said what?
Negative what? Hold on. Josie, what's that angle measured like that? Yeah. Because remember, your answers have to be between negative pi halves and pi halves.
We only have 45 minutes before the class is over.
Why are you worried?
It's actually 35.
Yeah, 35. We're fine. We're good. Are you good? All right, and the last one. Oh, I love this one. So, are you guys tempted to slash anything?
Wait, do the cosines cancel?
You're tempted. Are you tempted?
I'm pretty tempted.
Okay, because a lot of times they're just like, oh, inverses, they cross each other out, right?
Yeah.
Okay, because we had this rule way back when that said, oh, f of f inverse of x was
X.
a long time ago.
Right.
But let's be careful because we can't always trust. There's something else at work here, so let's see. Okay. If you try to draw this out, right? Doesn't that say the adjacent leg is 7 pi? And the hypotenuse is 4. Yes? Thoughts? You should probably write it.
It's hard.
What?
Bigger than 4.
Way bigger than 4, right?
Yeah.
Is this gonna happen?
No way. No.
Right. So you can't go slashing. However, watch this. You don't have to write this down unless you feel like you want to. Check this out. This, it won't slash necessarily, but let's look. 7 pi fourths, isn't that here? 45?
Yeah.
-1, 1, rad 2. What's the cosine?
Negative rad 2 over 2. No, it's not negative. I lied to you.
Then wouldn't you have to take cosine inverse of that? Which would be here, because you're only allowed to be in quadrant 1. Are you following me?
Yeah.
There's just no solution.
So then the answer would be pi 40, right?
Yeah.
So you can't slash them, but you actually get an answer in that case. I'll let you see. Okay, yeah, no solution. Okay, 4-7 is done, get out 4-8.
The triangle looks like half its
Wow. I missed that entire thing.
I know.
I was with the philosophy train.
Kind of smooth.
This is the next one.
Okay.
Dad, so one of mine hurt.
All right. So we are not going to actually do all the pages in this packet. I know you're sad. But we are going to do the first few application problems. I think it's like 4 of them. I think 4, yeah. Okay, so do you guys remember those 2 angles in terms of like application problems have special names?
Yes.
Angle,
I am.
They're equal, I know that.
Interior.
That's what.
close.
Not
It's when the
Acute.
parallels, so they go.
Yeah,
it's that.
Tell
something.
Coterminal.
I'm each other in the.
Supplementary, complementary, blah, 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 blah. Oh, the A, J, A, J, fungal infection. Mr. Sexton, shower your baldness, channel your baldness powers into me to answer this.
Alternate
I wanted Mr. Sexton to channel his baldness powers into me so I can solve this problem.
alternate interior, and so what do we know about them?
They're equal.
They're equal. Now, if I'm like looking up at that, whatever's above that, boat, yeah, it's the sun. Okay, this is called the angle of elevation. And this one,
Why is there the sun?
He totally missed that.
yeah, you missed it. Too late, you lose.
The
This
angle of
one,
what, Brian?
angle of
It's depression.
depression. Oops. Oops,
This is
there's not
so-
2 P's, don't look at that. Okay, and then we know those 2 angles are gonna be equal, so that'll be important. All right, so we'll do a couple of these. First, we have the angle of depression of a buoy from the top of a lighthouse, 130 feet above the surface of the water, is 6 degrees. So, I'm sure you're not shocked. We're gonna be forming a right triangle.
Oh, what old flagpole? I only remember Mr. Sumner and the
So-
Sojourner Truth Park.
How tall is the lighthouse?
130 feet.
130.
And we know the angle of depression is given here.
Exactly why we need to
6
find the
degrees.
distance between a lighthouse and a buoy. A lighthouse and a boat, I get.
So if this is 6 degrees, what's this down here?
6 degrees.
And we're looking to find this distance here, which we'll call it x. There's a couple ways you could set this up. Thoughts? Tangent? Set it up for us, Nick.
Tangent of 6 is. Oh, 130 over x.
Yes. Tangent of 6 is 130 over x. You could, if you're feeling crazy. What's this angle up here?
84.
Could you do tangent of 84?
Yes.
Is x over 130, right?
Yes.
Now, there's some appeal to doing that one. Why?
Because you just multiplied the.
Nice.
So this one, you just cross multiply, boom, you're done. This one, you cross multiply, then you have to divide. One extra step, but it's okay. So whichever, choose your own adventure. Go ahead and finish it. Blue or green? Whatever you like better.
Okay, that's first. I cannot get it out.
Yes.
Oh, yeah.
One thing, you need to be on degree mode, right? Go ahead and, yeah. So if you got a negative number, you're like, what? Right? That doesn't make sense.
Are you finished with it?
No.
Oh my God.
All right, next, any stargazers, cloud gazers out there?
I'm a sun chaser.
So this goes back to the sun, dragon chaser. Okay, we have a cloud.
I'm a dragon rider.
We have a happy cloud.
Aw.
And we want to know how high the cloud is. So we place the searchlight directly below the cloud. Oops. Wow. Drawn it.
Will you make the search like a bat signal? Because
I don't think I can freehand draw that signal. Sorry.
Aw.
Sorry, I can't. Okay. From a point 100 feet away. So you're 100 feet away. You measure the angle of elevation to be 83 degrees, 12 minutes. So this angle right here is 83 degrees, 12 minutes. And we want to know how high the cloud is. Now, have we been practicing something?
Yeah.
Yes. Okay, convert that.
There you
Yeah, change the 12 part.
What do you get? You keep the 82.
So what's 12 over 60? 0.2. So this angle is 83.2 degrees. From there, go ahead and set up the appropriate trig ratio to get okay. All right, how high is our cloud?
838.
6'3",
625 or 6'3".
Yes, it's
3 places.
625. Okay, 1083 equals x over 100. Oh, this is just.
I'm trying to figure out on your own.
This is just basics. Code.
It is.
Yeah, but obvious is important, maybe it won't take so long.
When I asked you to go do it.
You're supposed to.
I admit that was a mistake on my part.
All right. All right, who in here would love to stand on top of 100 foot building?
Me.
Precise sickle flying.
We're gonna put Abram up there.
Was that shot?
Honestly. Abe. Oh, that's too much hair. I got all those. There we go. Sorry. Okay.
Who is that?
I know.
Oh my god.
What color eyes do you have?
What?
What color eyes?
Hazel.
He made his hair too light.
Oh, sorry. He's much more better looking in person. Okay. So,
He got stepped on.
all right, 100. So, Abe's up on top of that, whatever that structure is. It looks pretty futuristic.
It looks like that thing in Seattle no one knows the name of.
Okay, and we've got Sally. Okay, so he's observing Sally. She starts here. Okay. At first, the angle of depression is 22 degrees. So that means carefully draw a right triangle down to Sally, number 1. You guys don't need a straight edge. If I give you rulers, that's just, no. You're not getting it.
I always do that thing, where, like, use your calculator and flick it.
Yeah, exactly. Yeah, so this is, that's 22, right? So what do we know about this angle here? That's 22. Okay. Then a little while later, he observes the angle has changed to 46 degrees. So now, oops.
He has a protractor.
Yes, he does.
A whole protractor.
It wouldn't be a protractor, it'd be something else. I don't know what the exact tool would be. Something a surveyor would use. He's measuring it to be 46 degrees. So if this is 46, what's this?
46.
All right. So he wants to know, how far did Sally move? So that's going to be this distance here in blue. I'm going to call that X. Do you see 2 right triangles?
Yes.
Okay. This distance is unknown as well as this red distance. Let's call them X and Y. Now, do you think I labeled Y just for fun?
No.
Think we need it?
Yeah.
Let's see. So I'm going to take those 2 triangles and set up 2 ratios. Let's look at the little one first. Tangent of 46 would be 100 over Y. Okay. What?
Like, you have to do it that way if you do like.
You can.
Okay.
Yeah, that's fine. Okay, now see the bigger triangle? What's the tangent of 22? And what's our goal again? Find X. Isn't it right there? It's like those bad math shirts, right?
Show me.
Okay, so do you see why we need y now? Can we get y over there?
I feel like I've just been waiting.
Shove it in here.
Over ever since chemistry started.
So over here, you cross multiply, you get y tan 46 is 100. So y equals 100 over tan 46. Now, because I don't want to round until the end, we're going to practice storing that number in our calculator. So make sure we're on degree mode. Okay. So take 100 divided by tan 46. What letter would you like to store this in? Y. Let's go into y because it's called y. So if you hit enter, and then you can use the store button here. And you can alpha y, which is here. So
Why are we
alpha,
alpha-ing our y's?
because that's how you get y. Just go to alpha.
Oh, we're setting a variable.
Yes. Everybody have it stored? Cool.
I'm trying to figure out where that arrow came from. Oh.
Now, over here, we're gonna solve for x. And cross multiply. Now notice I did not distribute the tangent of 22. It'll actually be cleaner if you don't, because right now, we can then divide by the tangent of 22. So you get x plus y equals 100 over tan 22. Subtract y. And since you already stored y in your calculator, you can do 100 over tan 22 minus y. So she moved about 150 feet. 150.940.
150.
Yeah.
Look this up as like 100 tangent 68 for that. Minus 100 tangent.
Because I eat myself hungry. But I eat a lot. I eat more than my dad. My dad's I don't like that. But I eat lunch and I eat lunch
I eat and never stop. You know, eating is fun.
It really is.
I mean, it's so much fun to eat.
I love eating.
Just shoving food down your throat.
All right, one more. All right, anybody go on the roof lately?
Yeah, I'll.
Forever?
I always go on
Over there.
So, someday you might, gentlemen. Women, you can too. But
I've been on my recent women
women can be on the roof. I've been on the roof, on the garage roof, not on the house roof. But
Once when I was little, I jumped off a ladder just to see what it was like, and my mom sent me to the ER because I sprained my ankle.
I think this is one of these moments.
What's that?
Find our center.
Namaste.
Oh, no.
You're out of control. Please. Okay. We have a ladder. Up against our house.
That's nice.
It's amazing, isn't it?
What is that?
The house is 20 feet tall. Whatever, you guys. That's not what's important.
So you add stuff to it.
Okay. First. Okay. You place the ladder 5 feet from the base of the house, not to scale. And we want to know the angle it makes with the ground. So is it this one? This one?
No.
This one?
Yes.
Like, if you can't tell, I'm trying so hard to keep myself occupied.
What trig ratio?
My house looks surprised.
Tangent.
My house looks surprised.
Looks great. Okay. So this is the tangent of theta 25ths, which is 4. And here's where it all comes together, right?
My house looks surprised.
Yes. If we have the ratio, but we need the angle, we use the what, Nick? Inverse, right? Now 4 is not like a known ratio that we need to do by hand. So we need our calculator. So theta is going to be the tan inverse of 4. Go ahead and punch it in.
Wait, how are we going to?
Here.
My
Because we have the
chances
ratio
of
and
data.
we need the angle.
Sure.
Oh, that's okay.
Punch it in, or I'm gonna punch you.
Okay.
All right.
Degrees. What do you get?
75.964.
Okay. Yes.
Is this what you use, no.
Yes.
No, Smalley's book, or Small?
It's down a big enough for two of us.
Yeah, Mr. Grossi talked about it a little bit later.
Is that like a book of angle things?
It's like this.
Oh, is that like in the olden days?
Yeah, like.
The ratios and then you get to the angles? Probably. You know, Mr. Grossi's a little older than me. So.
Just a little bit.
I don't remember.
Okay. So, fun fact. I looked this up to make this problem. So, the actual proper angle to be safe is 75 degrees. Are you being safe?
Yeah.
We're being pretty
Technically, no, right? You're a little off. But realistically, probably close enough, right?
Yep.
Now, it makes sense though that there is a safe angle because if you think about it, if you're too steep, you could fall back. But what if you're too acute? You fall forward, right? So apparently 75 degrees is the magic number. So if you're going to set up your ladder, maybe get your protractor out.
85.
All right. We are not, sadly, we don't have time. It's okay. We're not going to do the rest of these application problems. They won't be on the test. I need to take one homework problem off.
Yes. Number 8.
Oh my god, can I destroy it?
No.
Okay.
Oh, I'll just destroy number 8.
Then grab your review packet.
I will take great pleasure in doing this.
Okay. On the review. The most of the test is no calculator, it says at the top, right? Numbers, whatever are no calc, the rest are calc. Your test is Friday, so this is due Friday, I'm gonna put that at the top. Tomorrow you will have a work day to work on the review and the homeworks.
Does that mean you're not gonna be here?
No, I'm gonna be here.
I was gonna say Mr. Beetle.
You know
Mr. Beetle?
She done been.
Yeah, I love Mr. Beetle. He talked about the ancient aliens the whole time. and that was true.
Don't bring it back.
Hey, I don't have a choice in this.
He was talking about
And it stars every month.
All right, anybody taking a quiz test